Good evening, Professor. This is my MMIC book Chapter 1 review assignment. The Chapter 1 talked about IPD, an overview of IPD, and the thin film integrated passive device, or in bracket TF. IPD has become a growing industry driven by microwave, high frequency LED digital devices and the mixed signal. IPD is about integration, and this integration helps in the reduction of size and improvement in performance. The development of compound semiconductors has come as a solution for radio frequency integrated system. Example of this radio frequency integrated, these semiconductors, example of these semiconductors are the gas, the InGas, and the INP. They have an advantage of high electronic mobility and good installation property at high frequency. The monolithic microwave integrated circuit, or MMIC, is the integration of radio frequency active and passive devices on single substrate using semiconductors. As the gas developed, it also resulted into as the gas semiconductors developed, it also resulted into rapid development, very rapid development of the MMIC. What are passive devices? There seems not to be any agreement on a passive definition of what passive devices are, but the general consensus seems to be that these are basically integration of resistors, capacitors, and inductors. They optimize device performance and compensate for deviation. Now, IPDs, or passive devices, IPD technology has attracted much attention in recent years, and that is owing to the reduction of mobile devices, reduction in size, and the reduction of the cost of the devices, improvement in functionality. IPD containing passive circuit components like inductors, resistors, and capacitors totally integrated on semiconductor substrate. IPDs transform circuits using RN into ICs that are much smaller, more precise, and can be manufactured with good repeatability. IPDs also integrate individual passive components into microwave devices and systems. Application of IPDs. IPD applications that uses IPD devices. These IPDs already applied to front-end models of mobile systems. IPD application in the mobile. There are several devices within the mobile that are made using IPDs, and these include the filters, the balance, the difflexers, transformers, directional couplers, and the power dividers. Additionally, existing active devices compatibility with application of IPD semiconductor processing. Performance of mobile wireless phone and communication system does not rely on excellent design, but also depends on the characteristics of the materials and technology used for fabrication. Market demand for high performance and more compact electronic products is behind the integration of components. The next generation of radio frequency model offer optimal value proposition in terms of electrical performance, miniaturization, density, flexible system in package configuration, and the lowest bill of materials. Examples of the next generation of models are the 5G, the G, B, UWB, and LTA. And the IPDs are also spreading across all the sectors in electronics, from communication, aeroplanes, personal computers, military, medical, industrial, and lighting. IPDs are becoming IPDs are booming area in advanced packaging. Many electronics are featuring more than 500 passive components. Hence, conventional packages and the board assemblies are problematic in performance, yield, and the cost. IPD market has the capacity to expand from $820 million. The thin film integrated device or TFIPD is growing faster at a rate of 12% increase. A rate of 12% increase is expected in the coming years. This is the illustration or the market focus of the IPDs from 2010 to 2017, and it is courtesy of Yole Development. These devices are built on gas thin film substrate. The IPD is initially combined with the woofer label packaging or WPL for minimum yield size and the low cost. IPDs are 50% smaller, 70% thinner, and it requires less space, that is 50%, on the PBC or the printed circuit board as compared with the conventional passive devices or the discrete passive devices. The two figures below illustrate the advantage of IPD. If you looked at the one on the left hand, is the discrete, where there are so many components, and when you looked at the right, it has an IPD where all the components are put into one package. Another way of integration is by building the device on the substrate known as integrated passive module or IPM. The technology is identical to IPD. This technology has the advantage of not needing extra space and eliminates some assembling steps. Another method of integration is to combine them on the wafer level together with the wafer level packaging steps. IPDs can be designed to be flip chip mountable, as well as having wire bondable components by using different substrates such as silicon, gas, and the glass. IPDs have become an essential tool for system in package or SIP realization over the last few years. IPD is bridging the shrinking gap between the CMOS and the CMOS ICs and the lagging package technologies. This is an illustration of wafer level IPD types. The below illustrate various thin film IPDs applications. These are applications that are having the thin film IPDs. An application of IPD products. IPD is a bridge platform between front end and the back end of the models, and hence has the TF IPD has a potential. Hence, the IPD has the potential to extend wafer level package and the through silicon via or TSV technology to many integrated circuit package solutions and the the discrete passive component industry. Some cost issues associated with IPDs have slowed their adoption, as they are still seen to be expensive. IPDs are basically they are still expensive, and this has slowed their adoption. However, IPDs should be looked at from the perspective of shrinking of space, performance. IPDs are not yet standardized, then hence a challenge is setting up a supply chain, meaning there is no standard set for IPDs. Each person can be able to design in a way he or she deem it. Here we looked at the organization of the book. Chapter 1 gives us a general information and reviews the advantage, packaging methods, and the applications as explained above. Thin film IPD, thin film integrated package passive devices, or TFIPDs. Chapter 2 talks about the passive device technology with different passive integration methods such as LTCC, thin or thick film IPDs on different substrates, and embedded IPDs, the IPD foundry environment, and the passive components library, the layout design rules, and IPD problems. Types of films. There are three types of films exist as explained below. Conductive films are those that are needed to carry current with minimum of voltage loss, such as the top and the bottom plates of capacitors and the spiral winding of the planar inductor. Resistive films are only used in making integrated resistors, and they need to be specified on the basis of providing predictable, reproducible values of resistance in sufficiently small footprint. A wide variety of materials could be used for this, ranging from resistive alloys, ceramic, metal, nano components. Chapter 4 is about the design, like the IPD design flow, wireless local area network, low bypass, long-term evolution, or LTE, band pass filter, or BPF, BALAM, LTE, power diver, and the RFDI coupler, and their basic theory, schematic circuit design, simulation and measurement results, and the layout performance of mean fabrication. Chapter 5, measurement equipment, settings on wafer, measurement and introduction to process control monitor of PCM, and power handling measurement are noted. Again, we say dielectric films are used to form integrated capacitors as a vast array of materials with a wide range of dielectric constants are feasible, from simple and field formers for low-value capacitors. Relative dielectric constant, which is K is equal to 2 minus 5, to amorphous metal oxides and highly ordered mixed oxides for the highest possible dielectric constants. Chapter 6 concludes the book with the achievements summary and the prediction of results for design fabrication, and also with some suggestions about future work. Thank you.